Hello. Some people call me Mac. Today I have a puzzle for you. Most people like puzzles. Back in the 17th century, Isaac Newton, very clever guy, dreamt up his equations of great variety, and in particular the measurement of gravity. But Isaac Newton, although he could measure it, could never say what gravity actually is. He did say it was a force from a distance, and in that regard he must have been absolutely right, because gravity has a profound effect over the whole universe. So the fact that the hypothesis that seems to be a mainstream thinking, that gravitational force is a pull, but never proven, because no one, whether Isaac Newton or anyone else, has been able to show what gravity is. Lots of ideas, but nothing proven. So the pull of gravity is a hypothesis, nothing more. So I thought it was about time to perhaps look at it a different way. And I am looking at it on the basis that the gravitational force is a push. You can push a cart or you can pull a cart. The force, in essence, is exactly the same. So on that basis, that the gravitational force might be a push. A hypothesis, yes, but worth examining. If the gravitational force is a push, what might be doing the pushing? I have latched on to H1 atomic hydrogen, which emanates from every star in the universe, in every possible direction, at light speed. And tiny though it is, one proton with one associated electron, there is such a mass of them that it is reasonable to expect that if they strike something, there must be a reaction of some sort. Action and reaction are equal and opposite. Physics, you see. So on that basis, how could it work? Perhaps a little illustration might help. As I see it, it's only my idea. Take bodies in space. Take this body in space. If you imagine that there is nothing else around, but there is the gravitational force as the push of H1, which comes from every possible direction at light speed. What will happen to this body if there is nothing else around? Essentially nothing. And why is that? Because the force here and here and here and here and so on is essentially the same, is it not? So there is no differential pressure, no delta P that would push this in any direction. However, if you take another body and you place it a distance from the first, then what happens? This guy is now casting a shadow over that one, and vice versa. And because of the shadow effect, the delta P there is different from the other side, and the same with this guy. And these two bodies will therefore be pushed together. And as they approach one another, the shadow must become more intense. I think that's a good expression. And more intense shadow, and in consequence, a greater delta P, differential pressure. So that the gravitational force, if it is delta P, increases as they approach one another, which is, of course, precisely what Isaac Newton said, and others. So, on that basis, where I am at this very moment, I am being pushed onto the planet Earth by H1, coming from every possible direction, but influenced by shadow, creating delta P. The differential pressure that, in my mind, is the gravitational force. I think that's it. What do you think? So, when you are with good friends, enjoying your lattes and your cappuccinos, take the time to discuss this matter, this hypothesis that the gravitational force is the push of H1 atomic hydrogen. Do have a nice day. Goodbye.